I want to talk about the agenda for today. And when we discuss the agenda, it's obvious to all of us that there is a lot of hype about intent-based networking today. So I suggested to my esteemed colleagues to kind of talk about these misconceptions and bust some of those myths that are out there. And when I suggested this to my esteemed colleagues, they put this spelling, and I guess it's okay with us to make fun of our accents, so I had to correct them. But we do want to bust some myths. So when I mention word myth today, it is going to be M-Y-T-H. So we're going to talk about that. Then we want to talk about what is the scope of intent, because that may narrow down discussion and actually help dispel some of those myths. As you see. Then we want to spend time presenting a view of AS from the developer persona perspective. And Derek has introduced these two personas. And we're going to spend a lot of time on that, but even more time we're going to spend with lots of demos and very concrete use cases. So with that in mind, what are some of the myths that we want to discuss? So one of them is that intent-based networking is about this all-encompassing magical abstraction that wraps hardware abstraction layer, and there is some canonical language that fixes all these problems. So, well, there is nothing wrong with the abstractions. We love the abstractions, but there are different abstractions that are used at the business level versus abstractions at the resource level. The point is that at the business level, rules are subject to such a change that you need to have different and flexible model, and you approach modeling very differently than you approach it how operating system approaches modeling resources. The second thing is that there is conception that is all about configuration management, and there is this, again, some magical translation that takes some declarative specification for the device and translates it into device configuration data. Very important problem, no question about it. There are actually many tools that do this very well, but it's only one part of the story. And the third one is that it's all about just validating network reachability, and it's all about physical network connectivity. So don't get us wrong. Physical network is very important. It's where the rubber hits the road. Actually, the tire maker Pirelli, who makes tires for Formula One, their motto is power is nothing without control. So essentially, if you are trying to build some virtualization layer on top of physical network, you better take control of your resources first. So what you will be seeing in today's presentation is a lot of thinking about how do we approach this problem and how do we enable these tools to the developer persona. So it's necessarily going to involve some architectural decisions and thoughts, but our goal is not to convince you that this architecture is good, or we don't want to get into those arguments, because in the end, the benefit of good architecture should be measurable increase in feature velocity, and doing that while producing scalable, testable, and maintainable code. And we want to show you that today. So now, let's talk about intent scope. So the first question is, well, what is intent? So I can say, intent is declarative specification of desired outcome. And you can tell me, well, thank you very much, Sasha. You just gave me zero information. Can you be more specific? So then the thing is like, well, what is the desired outcome? Well, the desired outcome is how to automate complete service lifecycle. And service lifecycle consists of these 4 phases. I'll mention them briefly here, and we'll spend more time talking about that during the presentation. So the first phase is a design. So what sort of intent you specify during its design phase? Well, you may say, I want to support 5,000 servers in my data center network at or a subscription factor of 1 to 2. And that's about it. And you can feed this to design calculator, and it's going to spit out some possible options for you. Once you make these options, you have some number of spines, number of leaves, number of links between spines and leaves. All of these elements are actually expressions of your intent at the design time. But does it end there? Well, no. If you want to now instantiate this design, you need to do some build. What is the build phase? Build phase consists of allocating resources to this design blueprint. And these resources could be soft resources, such as IP addresses, ASN numbers, or could be hard resources, such as serial numbers. But you're also making some other decisions in the build phase. You may say, I have thousands of fabric links, and I want them allocated from a resource pool. Or you may say, well, no, I have my numbering scheme, and I want them allocated explicitly through APIs. But again, the decision whether you do it one way or the other is, again, your intent, and that intent has to be captured somewhere. So when you're done with your build, you can start generating configurations. So deployment phase deals with config generation. Very important aspect, but not the only decision. When you do deployment, you may say, how do I roll out this deployment? Do I do it one device at a time? Do I do phased rollout? What do I do in case of failures? How do I roll back? Again, each of these decisions is part of network operator's persona intent and needs to be captured. Oops. And finally, our favorite phase is validate, which is the one that closes the loop with all these first three phases. Because when you push a configuration on the device and the device says, excellent, I accepted it, are you done? No, it's just where the fun begins. Because you want to validate that all artifacts that should have been there are actually there. So what am I talking about? Well, if you're building a L3 class network, when you deploy configurations on your leaves and spines say, okay, you say, well, it's a BGP L3 class. I should be having, as a leaf, very specific BGP sessions to all my spines. Given the propagation of routes that I expect, I know exactly what routing entries should be in which routing tables on which devices. So we actually perform this continuous validation of all these artifacts to ensure that actually service is operational.
What does that symbol mean?
It's coming.
Oh.
So symbol means you need to be able to actually react to change. But before that, let me just go into another aspect, which is intent is also serves as a single source of truth for all of these phases. And why is it important to have a single source of truth? So there was a paper published recently by a large web scale company that talks about their automation approach. And it has many excellent points in it. At the end, in the lessons learned section, they mentioned that there is an issue that they had which resulted in what they call stale configurations. And the root cause of that problem was the fact that they have different sources of truth for each of these phases. So there was a design phase where somebody would say, well, I want to build my pod like this. And that person A would then manually generate configurations, but let's say forgot and did not deploy them. And then the person B would come and make changes in the design, but not generate, because again, that's a manual process. And then the person A would then go and deploy the configurations. So now these configurations would be stale because they were not in sync with what was in the design, and that this caused some outages. And again, the single root cause for this was the fact that they had different sources of truth for these different phases. And now, again, none of this matters if you cannot react to change. And no, you have to take it for given that there will be changes in the intent. So where do changes come from? Change can come from the operator, because business rules will change. Operator persona may decide to do something. But changes can come also from the infrastructure, and you don't have control of those changes. Systems will fail. And your system needs to understand and know how to deal with these changes or how to report them. So if you don't know how to deal with the change, what is at stake that your greenfield environment is going to become a brownfield overnight. Because you're going to deploy your beautiful greenfield environment, and if you cannot deal with change, then somebody is going to go in and do manual changes, and you lost control of what's in there. So, very high level overview of architecture, just from the perspective that's what you need to get today from this presentation. So, there is AOS core component, which is completely not opinionated. And then there is an application component, which is where the developer persona or network architect inserts all his opinions, his constraints, his design decisions. And we'll talk a lot about how he does that. And then operator persona actually consume whatever developer persona has done through REST APIs and UIs. So now, what ends up happening? So what ends up happening is that you can have this application, for example, Data Center L3 clause is AOS-supported application that is a turnkey solution that you can use it out of the box, and operator persona can use it as it is. But then you can build your own application. Now, who is you in this picture? You could be, well, you today is Apstra engineers because we have built this platform so we can build these cartridges fairly quickly. But you could be a combination of network engineer and tools team at a customer. You could be a system integrator. You could be a community. So what will end up happening is that you're going to have applications that address different market segments: data center, interconnect, hybrid cloud, campus, whatnot. So now let's dig into this application architecture. What gets in there? What does developer persona build? So first, he has to store some intent, correct? Well, the question is, how does he do that? And we'll talk about it a lot today, but what is given to developer persona is schema. He will be able to define the schema for his intent. Use the existing one or extend the schema because, as we said, business rules are subject to change, and he will need to be able to modify the schema. Well, now that the schema is in there, what's next thing is, well, he needs to be able to programmatically reason about it. And you may ask me, well, what does the reasoning mean? Well, let's take an example. Let's say you have published some schema. One thing you want to do is do a semantic validation. So what is an example of semantic validation? Well, let's put it this way. Schema is going to help you with static type checking, so you're not going to be posting some data that is of wrong types. But a semantic validation actually is going to look at the network scope, for example. So to avoid outages like we have seen recently, you could have a semantic validation that says, I will not allow you to put more than 2 spines in maintenance mode. So if you have 2 different people logging in, putting spines in maintenance mode, the semantic validation plugin is going to say, well, no, that's not allowed, and it's going to prevent you from doing that. And again, you can express different rules for semantic validation. And again, it's under control of developer persona. Once you're done with semantic validation, I have pushed my data. What's next thing? Well, it's a resource builder. We discussed this resource builder in terms of, for example, was allocating IPs to fabric links. Again, you may put some semantic validation in resource builder itself. You can say, I don't want to be able to deploy my configuration unless all the IP fabric links have IPs allocated. Or if I'm specifying them manually, I don't want to have duplicate IP addresses. Once that is done, you do configuration rendering. Configuration rendering is, again, reasoning about intent. So what do we mean by that? Well, if I'm a leaf, to render configuration for this leaf, I need to reason about my context. Who are my spines? What are their IPs and ASN numbers? I may need to fetch some policies that affect how I configure things. So you fetch all of those things, and then you produce configuration. And we'll talk in detail how do we produce configuration. So now, is that done? Well, no. Now is the interesting part where you say, let's start doing expectations rendering. So expectation rendering is you auto-generate expectations that the system has to meet and auto-execute the tests, and then auto-generate anomalies if there is a mismatch between test result and the expectation.
So expectation is your name for unit tests.
Correct. You can say that. And then this actually triggers telemetry collection. So what we're trying to say here that we collect, our goal is to extract more knowledge by collecting less data. So we collect exactly the telemetry that we feel needs to be collected. And you can collect a lot if you want, but the point is it's pointed. It's not collecting telemetry, shipping it to some big data, and then it's somebody else's problem to actually correlate and figure out whether this is right or wrong. This extraction of knowledge happens within AOS.
So expectations is your future state after rendered configuration has been pushed to the device.
Exactly. We'll talk about it in detail. And then on top of that, we provide facade API so that operator persona can interact with this. And then we provide unit test framework because we want to build testable, maintainable code. So as a developer persona, Damien will be showing you some examples today. We have 800 unit tests to make sure that things work as expected. So let's start our journey into intent. The first phase is design. I mentioned this to you pretty much. It looks, let's say you have come up with some design constraint, and it looks like this. This is the diagram network engineers relate to, and you want to put this into intent. So how do you express this in the intent? So the answer to that is we use a graph model to express that. And we'll talk in a minute why do we chose that model, but let's just introduce the graph model very, very quickly. So a graph model has only two elements. One of them is a node, and it has a key value, set of key values. And then there's a relationship that has a name, and the relationship is parameterized by the node that serves as a source and node that serves as a destination, and it's directional. So as an example, if we were to model the system that we have described before, we can have a system spine 1 of role spine that has hosted interfaces relationship, two interfaces. An interface has a name and role leaf. And role leaf for this interface implies that this is interface facing the leaf. So now, why did we choose a graph model? So first of all, it's very natural. Network is a graph. It's important to express relationship between objects in both physical and logical domain. But even more important is the realization that the business rules will change. And you need to have the model that is easy to extend and adapt to changing business rules. And then the third point is that you will not know all the queries that you need to run at the design time. If you're doing SQL, your SQL schema is driven by queries that you expect to run. And if you later on decided to run a new query, and guess what? You will not know what queries you will want to run in the future, because when you start troubleshooting, you may want to look at a completely different perspective. The way to do this with SQL would be doing 5, 6 joins, and when you have this many joins, the performance is not going to work. So what happens is that with graph, you can efficiently run queries that were not even anticipated at the design time.
So it's my opinion that the hint there at the bottom is the main point for this slide. All through all those phases, design, build, deploy, validate, or operate, you really don't know what questions you're going to be asking the next day. If you're troubleshooting, right, someone calls you on the phone, they're going to say X is down, and then the only information you have to start with is X, right? It could be an IP address, a MAC address, a VLAN, a switch, a server name, and that's your starting point. And then you have to kind of go out from there, knowing which questions to ask based on your expertise and your knowledge of the network that you're troubleshooting. So if you don't know what questions you're going to ask, that also means you don't know what data you're going to need. What answers are you going to need? So by using a graph model, it's very easy to extend the model. And this is really important, because the network today is not going to be the network in a year. It's going to be a different network. It's going to have grown and evolved. You might have added features. You might have changed the shape of the network over time because of design constraints or other constraints that surface. So that's really the main point. And when we say networks are intuitive, we don't mean, people immediately resort to there's nodes and there's relationships. Okay, then I have a router and a switch and there's a link between them. But we're really talking about all the network knowledge that you have is really in one huge knowledge graph. Like, that if you trace the path of a packet through an infrastructure, you know that it hits a transceiver first, so there's show commands for transceiver. You know that it goes into an interface and that there's policies applied to the interfaces, right? ACL, QoS, PBR, and those execute in some specific order. So you're going from hop to hop to hop, evaluating what could happen to that packet in the path. Then it gets forwarded to an egress interface, et cetera. So your entire network knowledge, your understanding of networking is really one huge knowledge graph. And that's what we're really capturing with this graph is those relationships inside of a network.
And you mentioned the word policy, and there were questions about how does policy relate to intent? Where there is intent here, policy is there, how do they relate? Policy is part of the intent. It's as simple as that. It's what you're trying to achieve. It's 15 years ago, we could have called policies intent. There is no magic there. It's that the problem is that you have to have single source of truth that captures all of that. So now, So moving on with this, this was the design. The question is, how is this design now represented as a graph? So let's walk through this example. So I have two spines. There are two spine nodes that represent spines. Then I have now 4 interfaces. I have 4 relationships with each interface. Then there is an interface node. These relationships are named and typed, but we are not showing that here because it would be a clutter. Then the interface is attached to a link, and then the link has a relationship to interface on the other side, and this interface is now hosted on leaves. And now this is your fabric, but then leaf has continuing southbound, has interfaces facing the servers, and there are server links, and then finally interfaces on the hosts. So what does the model schema looks for this? And this is a subset of our model. And our model is slightly bigger, maybe a dozen classes or so, but it's not 2,500. With these 3 classes, we were able to model this physical layout. We showed here, for an example, how does virtual network come into that modeling? Well, you model virtual network endpoint that is hosted on the system and it is member of a virtual network. So when you talk about how do you actually integrate and correlate, underlay and overlay, it's a model like this that can help you achieve that goal.
A few questions?
Yes.
So when you model link, do you include link state attributes such as load on the link, capabilities of the link?
Correct. So we perform telemetry, and telemetry is gathered for the link, and then this telemetry is keyed by the link ID.
So you keep it in key value store and you can address it.
Correct. But we use the graph to reason, to get the keys and then access we don't overload this node with all the state that it needs to be there. But for example, if you generate anomaly for a link, it is going to be accessible through the graph query.
So could the value in the leaf trigger reoptimization or change in weight on the CMP hashing buckets?
Yes, it could.